Hello everyone, welcome to my FYP1 proposal defense. My name is Joao Yongshen, my student ID is 16001801, and my FYP supervisor is IR Dr. Patrick Sebastian. My FYP title is Crowd Real-Time Video Classification, Count and Flow. The background of my FYP is the current situation in security or crowd surveillance is that it is typically used for large crowd monitoring or observation. In a crowd in a public area, there will be a mixture of people which should consist of males, females, or even children. The mixture of people in the crowd will differ from location to location depending on the utilization of the place of congregation. The problem statement for FYP is that there is no definitive method for accurate and real-time determination of the composition of a crowd, segregation of the head count, and direction. And also, the typical usage is done on still images, and it will be quite difficult to apply on live images or on a live video stream. The objectives of my FYP is the determination of the method to be used with reference to real-time video processing, as well as to ensure the accurate or increased accuracy of segregation of individuals from a live video feed, and to ensure accurate determination of the direction of crowds and the count of different individuals such as males, females, as well as children. The scope for my FYP1 is to do research on deep learning and methods of object detection, as well as apply and compare human detection algorithms on sample videos, research and apply methods to reduce the processing time on human detection, as well as apply live video feed on human detection. This is my literature review that I've done. I focus on object detection methods and object tracking methods. So for object detection methods, we have the single shot detector, which combines regional proposal and object detection method in one shot, which outputs the object class and bounding boxes only. While for master RCNN, it is an improvement from the faster RCNN architecture with an added ROI line layer, which then requires two shots for regional proposing and object detection, but it outputs the object class, bounding boxes, and the mask. Of object tracking, more specifically delete object tracking, it estimates the next position and the scale of multiple targets using the fast scale search, which implements two separate filters for translation and scaling, and this object tracking algorithm will be implemented in parallel with object detection. The methodology used for my FYP is to use an IP camera to access a live video feed, to use deep convolutional neural networks for feature extraction, single shot detector or mask RCNN for object classification and localization, which we'll be putting under the same family as object detection, delete object tracking for object tracking, arithmetic operators in Python for object direction and counting, and lastly, we will be using output screen for the processed video frames. This is the implementation on the project so far. So for human detection, I've completed and I'll be demonstrating it in the next slide. Gender detection is in progress as I need to retrain and test the object detection model and apply the new data set into the project code. For object tracking, I have completed it using delib object tracking, which I will demonstrate in the next slide. Object direction and counting is still in progress as I need to add arithmetic operators to calculate and compare the distance traveled by the bounding boxes using OpenCV's library in Python. Lastly, live video feed is also in progress as I have to look for a suitable IP camera to obtain a live video feed via its IP address. So this is my project progress so far. For object detection, I've done on single shot detector and mask RCNN. I've got the sample codes online and I applied a 42-second video into both algorithms. So the single shot detector took 408 seconds to process a 42-second video, while mask RCNN requires more than 2000 seconds to process a 42-second video. So logically speaking, we can't apply these two algorithms for the live video feed as it requires more time to produce to process each frame than the time of the frame itself. So I use delib object tracking. So what it does is that it skips 30 frames on the video, and every 30 frames we'll be using it on object detection algorithm, while the remaining 29 frames will be running on delib object tracking. So what it does is that it decreases the processing time for both single shot detector and mask RCNN, as we can see here. So these are the sample videos that I have prepared. So the video on top is for single shot detector plus delib object tracking, while the video below is from RCNN plus delib object tracking. So as you can see, the single shot detector has successfully detected the humans in the frames while successfully tracking them as well. However, for master RCNN, there's a bit of difficulty for detection as well as tracking. So this is a short demonstration of my work so far. This is the conclusion of my work done so far with SSD and masked RCNN with DLib. So as you can see, the accuracy for SSD is much higher as it detected all the targets as no mix-up, and the tracker only lost its target on one instance, while masked RCNN had failed to detect one target, one mix-up, as well as it lost its target on multiple instances, not to mention that it had a higher processing time compared to SSD. Hence, the SSD with DLib is much more suitable for real-time human detection and is more suitable for my project implementation. So lastly, this is my project timeline, my Gantt chart. So on week 1, I've done my title selection. On week 2 to week 6, I've done my literature review. From week 2 all the way into week, FYP1 and FYP2, I'll be doing my software development. My presentation slide will be done on week 6, and then my proposal defense will be submitted on week 7. The interim report will be done since week 2 and will be submitted on week 10 and week 12. So that will be all from me. I believe the Q&A session will be done offline. So yeah, that'll be all from me, and thank you for your time and have a nice day.